Hello, everybody. I'm Larry. Couldn't do the contest this weekend. It was Halloween weekend here in New York. I dressed up as a kangaroo if you're interested. But maybe I'll put up a picture if people leave enough comments for me to. But yeah, so I'm going to do the virtual contest for the one that I missed. So just it's good practice. So let me know how leave a comment or whatever. But I'm going to start now. Thanks. This is the first time I'm seeing these, so hopefully I'll do well, even though it's not counted for views. But anyway, cool. Yeah, so this is the first problem. I think as soon as I saw the function is constantly increasing on the top, I knew exactly. I mean, I had a rough idea that is the thing where you try to find the diagonal so that it reduces the search space from x times y to x plus y, and the rest of the problem is just dealing with getting that right. I think this is a little bit hard for an easy problem, but I guess there's a difficulty inflation these days. Um, but yeah, I think over the next couple of minutes, well, here I'm just reading it again just to kind of see the interface and what they're asking for, and kind of making sure that yeah, that it's kind of in a good place. Uh, just verifying my assumptions by reading. I think right now maybe I'm looking at the x y is less than 1,000, so I'm like, I think yeah. At this point, I was debating whether I should do just like some x times y is 1,000. 1,000 squared is a million. That's not so bad, right? Um, but I was also a little bit worried about getting an unnecessary time limited when clearly they set up the question just so that you can do it in x plus y linear-ish versus x times y. Um, so I was like, it's not worth me doing something that silly. So you probably can still do x times y with some kind of like binary search type thing so that you cut it down. But I didn't find the x plus y solution to be that complicated. So yeah, it was a weird question. Here I realized I had my data type's a little incorrect, but not a big deal. I was missing a semicolon, but I actually don't remember when I caught that. But yeah, here I'm just in that diagonal thing determining where you want to go, left or down essentially, and whatever gets me closer. So here I did spend a couple minutes debugging this because I should have fixed something that I didn't. I wasn't sure. Actually, when I implemented this, I wasn't sure the direction of the greater signs. Like I didn't know which one should be the smaller one, and it wasn't super clear. But I figured that it was one way or the other, so I do a quick one of the tests, and if yeah, it's one way or the other. If it's really wrong, then I know that I just have to invert it. So I wasn't really that much worried about it. That's when I finally realized I missed a semicolon. Oh, usually, yeah. I know, so I might as well put in an extra test because I feel like I was confident-ish about this, and then I was a little sad when I looked at it and I'm like, that's not right. So good. But that's because I didn't compare it to Z or Z. Maybe the other way around. And here I was like, oh, maybe it's the other way. That's which was even more wrong. So. I think at this moment, I'm like, I just print it out just to make sure, see what I'm seeing. I'm like, man, this prints way too much. It's not that helpful for debugging. It's like, gotta change the input. So I just started. I changed it. Yeah, I just changed the starting values just so that I could kind of see the bars. That makes sense. And here I noticed that I was kind of going down to a route that I was like, maybe that's not exactly what I want. I just want to print out all the choices as making it why that's the case. Yeah, here I'm like, I'm looking at the choices and it's like, well, going, like it makes sense, but it's not going back to the 5. So I was like, okay, well, I probably need to change my my testing function, but maybe still thinking about it what I'm doing at this point first. And looking at the next step. Yeah, excuse you. Yeah, and that's when I finally put in the like whatever's closer to Z. And we I think I had a couple of things of like starting at zeros and stuff like this, which I clean up. And I was also wondering why it's missing 1, 5, but that's because I started 1, 4. So which I also thankfully says test caught. Oh. After that, it was a submit. I think I was a little slow, and this one is like 7 minutes, which is not that. Actually, considering the number of debugging I had, it wasn't that bad. Yeah, problem 2. Me was just reading this one. I think I might have made a comment very soon about how this is there's a name for this. Yeah. Actually. Yeah, he may make a comment on it like in another minute. What it's called. So, yeah, okay. But I do remember later. But it's basically the Aurelian cycles or path cycle. Well, cycle because you want to get back to the first one. And the thing to note is that and I don't really which am I call it? Aurelian circuits. Yeah, there you go. Aurelian circuits actually. Yeah. And I don't know how you would solve this without this information priority. I mean, maybe you could prove it a little bit over time, or at least prove to yourself over time, which is fine but hard. Which is that for each node being each number actually has 2 paths in and 2, even number of paths in and even number of paths out. Just to change the parity. So because knowing that, you cannot get stuck in a dead end, if you will. As long as you go in and out. So knowing that, which requires you to know that for one, allows you to basically use something that's like a greedy. You could just keep taking the first path in and out of wherever you, first path in and out wherever you are, and then just keep going. And because I knew that ahead of time. I knew that I could say myself like so it's essentially greedy, um, and you don't have to do some like depth first search or backtracking or whatever. Even though you do a you do a depth first search or backtracking, you'll probably get the result very quickly. Um, and that's essentially what I did. I think I just keep track of the states that I've seen, and then
Hamiltonian
I just
path.
go. I mean,
Okay.
I think I was a little yeah. I still wanted to, like I wasn't super sure that greedy was well, is that, I don't know if I would consider it greedy, but just taking the first route I was good enough. But at the time, that's why I'm like I think at here I'm like googling orient paths just to make sure. Well, or like something with like a sequence or something like that. But yeah, at some point I'm just like whatever, just code it.
You're probably just greedy, I think. Could be wrong.
Now I just have this set of things I've seen. Always forget it was insert or add, and then I just do that here. I mean, this part is just very standard stuff. It's like, oh, if we haven't seen it yet, then we make this a new thing. I have a typo here, but I guess I added like a couple of seconds, which is unfortunate, but yeah, when I start testing right now, I also add a test about time limited.
Mm-hmm.
I was like, huh, what is wrong? I mean, that's not even close. But it found the bug pretty quickly because it doesn't really make sense otherwise. But luckily,
no, but that's actually big. Right?
Yeah, I got to answer very quickly, but want to try the max case, which is 16. That one's okay. Okay, let's see. At this point, I was still not super confident, to be honest, that it went in time, but surprised. But once it got accepted, I'm going to ignore it. Cool. The third one, yeah, I mean, I think this is a very straightforward brute force. I think the first thing I noticed was the n is equal to 16. I think that's, yeah, and when n is equal to 16, then you know that you could run something like n to the n times 2 to the n, and times that by 26 or something is fast enough. And I think, yeah, and that's where I started looking. I'm like, huh, can it really be? I think some of my slowness here was my hesitation of whether that is fast enough, because I was like, wait, is it? I mean, is it true? I mean, you know, the two brute forces in a row. Like, yeah, like, is there really two brute force in a row where it's just 2 to the n? Yeah, like, and apparently the answer is yes. I was just like going over like whether that's the case in my head.
And this is just brute force, I think.
And just took a quick look at the last part. Just to see if I need to switch, if I think it's easy, or if I'm like, I just want to just do it. It's easy-ish. This is nonsensical, but I think I recognized that very quickly, thankfully. And this is just standard 2 to the n using, just doing the math just in case. Yeah, using the binary representation of I as the bit mask.
Times 16, so that's 1 million. That should be okay. Times 26, 27 million. Okay.
Yeah, I think in competitive programming, you have a running counter of what's fast enough in your head. But I just wanted to double check. So I think I just pull a calculator to be like, 2 to the 16 times 16 times 26, which was fast enough. Well, seems to be. And I think while I'm here, because I think he just programs the rest of it now, you could actually, if you do this recursively, you can probably remove a lot of possibilities because you just branch off a lot of stuff that cannot possibly be overlapping. But that doesn't fix your overall time, but it does help. This is more C++ way of doing that, but it's fine. Yeah. And I would also say you can actually optimize that by using a bit mask, because there's only 26 characters. But I didn't do that. That would have probably saved some time, but I don't think that would have been make or break. But it is expensive. Probably shows up. Basically, it's just, and this is just to keep track of what characters we've seen, because we cannot see more than one of them. And then it's still good. We just add it to, or we take the min of that, or max. Yeah, max of that in this case. Oh yeah, I have to count the characters, which there are a number of ways to do it, but I just did it this way. Yeah, this part I was relatively confident. I don't know if I'm, thanks for seeing if I made any more changes, but definitely was putting into more test cases. Well, I mean, I always try to do at least like the yeah. Worry about time limited there as well, but seems fast enough. Yep, worry about time limited, but cool. This farm. Yeah, I mean, I think this one I might have to do a little bit more research on afterwards. People got it really fast, relatively, I think, and you could. I think what I actually end up doing is Googling example 3, because that's not axis aligned. Otherwise, you could just do some. Yeah, he didn't finish that dot, but yeah, it was axis aligned. Is what 169. If it's axis aligned, then you could use dynamic programming to snap it off. But the example that they give you, which here is 11 by 13, which has that little one thing in the middle, which bothered me a long time because I didn't know how to resolve that. But eventually, I think this is like maybe spoiler alerts, but you'll see me go in the future. where I
What am I doing?
I was like, maybe it's greedy as a result, but I couldn't
Okay.
really figure it
Yeah, I
out.
just
I
have
was
to
like,
do that in real life.
yeah. I noticed that I had good timing on the rest of the problems, but like I said, previous me said, you just have to do that in a real contest and not in a virtual contest. But that's another story. But yeah, I think like I did end up at some point googling this, and I was trying to avoid obviously the Leetcode reference ones, because it just feels like a very common problem that people have looked into before, and it turns out that the 11 by 13 case is the only case where things are not
there's some kind
axis
of
aligned.
I think you could do some kind of brute force type recursion type, maybe with memorization, but how do you do this?
Yeah, I did think about trying to do some recursive brute force thing, but I just couldn't really figure out how to do the data structure in a good way. So yeah, and then after that I did the Google, and then and obviously I tried to avoid the answers, but apparently there are papers on this, which is actually like kind of crazy that you expected to solve in, I don't know, 40 minutes or whatever it is.
It's hard, and 200 people got it.
But yeah, here I'm just amazed that a lot of people got it very quickly. So maybe a lot of people got it at all. But yeah, I do eventually go to implement the dynamic programming for the smaller n times m's and hard coded the 11 by 13. I should go back and kind of see what the right solution is. Or maybe I'll do a retro on this afterwards. As of right now, I haven't. But yeah, I think after that, I don't know if there's that much for me to go over in terms of
no, don't tell me the answer.
Commentary. No, I think I just went. I clicked on this by accident. I didn't want to see it, but yeah, we'll let past Larry talk about it then.
Can you do something greedy brute force?
Yeah.
Simplification is that it's a square, so maybe there's some properties there. Like the base. There's a lot of counting there. Maybe some sort of sweep line. What the wow. So as I said that people already solved this. Probably have seen this before though. But wow. I think it's greedy brute force, but I don't even know how to begin to implement it. It's either that or you just need the 4 corner squares and then everything else just fill in a weird way. Yeah. And you could brute force on the 4 corners or something with some special cases.
But right now I'm just thinking about the data structure to even enable that. Let's give it a go. Well, and then just return 1 because that's 1 square. There's some crazy Fibonacci stuff here, but that doesn't apply here, so maybe that's just a weird edge case. Also fun to look at. I think that's actually one of the thingies for Fibonacci's, but one of the visualizations. But let's say maybe my naming is terrible. Maybe I want with actually. Now we want, so top is you gotta say as that as well, right? So we're going to check that way is greater than 0. Otherwise we continue. Oops, this is not true. Otherwise, well, so you could always do that. Oh, 1 square here. Maybe even have the right corner. So now the other corner will have height minus, right? I wonder if you could always just do something like, I don't know. No, because then yeah. So now you have 4 things and you try to tile them. Actually, may not even need this other. I mean, I guess you do in some case, but you try to do the 6 all the way up, 4 all the way up. Maybe.
That's tough. So you definitely need those to fill the gap, though maybe you could, in theories, you could do that by ones, but then you just move them to the right anyway. And now we extend the top and the thing. Man, people are really fast on this one. I really don't have a great idea on this one, but people do. Maybe I could just do this thing. Like, how do I decide between this and say another 4? I wonder if there's some crazy thing where you could always tell by like some small amount, because you can always do a close approximation with 4 squares. I feel like I don't know if this is like a worst case even. Like with 4 squares, you do most of it and then just fill the other one by ones. But that's very greedy though. Well, maybe 13 is small enough for me to do some. I don't even know how to do a brute force. Then we put this 6 on this corner, on the upper right, for example, because it chops this one off. Apparently it's solvable. And solved by 200 people.
Maybe we could do something with dynamic programming. Just keeping track of number of spaces and the maximum number of squares that you can fit. Is that even good enough though? Like, I guess after you minus 7, what does that mean, right? So you put a 7 by 7 square, that means you have 6 on one side and 4 on the other. I don't know if that's a easy recurrence to write. I mean, I think the trivial dynamic programming is just, if it's axis aligned, you just cut it off on one of the edges. But this one's the tricky one. But maybe that this, 6 is the worst case. People just Google doing tests or doing these things. But I've been Googling wanting the answers anyway. So, and it seems like people are saying, even outside of just solving this, is saying that this is the only one that it comes up with things on that axis aligned. So I'm just going to try to hack that out. Let me just go DP, right? x by y, doing x by x square, and you have a x by y minus x. Okay. Or the other way around, I guess. Seven by six, how do you get 5? So you have 6 by 6, 1, and then you get 7. That's how you get 7. How do you get 5? How do you get 5 by 7 by 6? If I missed a case where I'm trying to squeeze in, let's say you have 4 by 4, 5 by 5, 5 by 5. Yeah, right. If it's a square, then does that help enough? Nope. Alright, I need paper. So 7 by 6. Not 3 by 3, because then you just have 4 3 by 3s. Does that make sense, right? What is a 6 by 7 answer? I can't even construct one manually. Oh, if it's 4 by 4, then you have. Now that didn't mix. Well, and it's 3 by 3. I can't even visualize it. Man, I have to. Let's say we have 4 by 4. That's 1. Okay, so I guess 4 by 4 has this thing where. Oh, wait, I'm missing some cases. That makes sense, actually. Okay, so what we actually want is, instead of cutting off the biggest square, you do something like x. No, that's. Well, I mean, it'll be y in this case, but actually what you want is similar to I plus something like ix or something. Something like that. Better. Still wrong though. I think I'm missing something. Oh. So now it just gets into infinite loop, so maybe not. Yeah, this doesn't make sense. Argument. It's okay. So we want in this case we have 7 by 6, which we put actually into 6 by 4 and and 6 by 3. Okay. Actually, one. Actually, the recurrence is actually some. Oh man. Okay, but now I think we also want it in the other direction. Okay. It's alright. I guess we'll wait till the end to see where I end up. But yeah, I'll go over each of these problems. I don't know. I guess Googling is not part of the thing, but I don't know. Let's go over each of these problems real quick. I mean, I know that maybe I want a commentary and you've already heard it, but cool. And then we'll see the rank at the end. Find a positive integer solution for a given equation. So this is based off the. I think this is it's kind of. I think some of that is crazy to me in the sense that I think there's definitely like these have gotten more difficult over time. Where this is probably not easy. This is probably like a medium in no sense, but of course, everyone should know this, or at least it seems that way because most people got it right. But the idea is that it's a very traditional problem where things are monotonic. If you go, so you try to do this thing where you walk the matrix of your row of x, y, so that you you only walk the diagonal because there's only a diagonal in which this could be true in some way. I mean, it doesn't have to be a one-to-one diagonal. And instead, you get an x plus y timing instead of x times y timing. So that's how you would solve this problem, and that's essentially what I did. And then just kind of make sure that it's close to the function we're looking for. So that's a very brief case. Circular by permutation. To be honest, I don't know how you would do this normally, or I don't know how you would derive this. I think some of the stuff that is because I do know how to solve this, in that I have some experience with this before. Mostly because because this is a Euclidean circuit, you know that wherever you go, you cannot get stuck in a place because if you look at each state as a node, there are even numbers of way in and out. So if you go in and then you go out, you'll preserve that parity. So as long as you keep doing that, it doesn't matter which path you go, you always get an answer as long as you just pick an edge that is available. And that's essentially what I did. I don't know how you would kind of prove to yourself that that's true without knowing that a priori. I mean, maybe you could figure it out, but it's pretty hard otherwise. I don't know. But that's essentially what I did, right? I find an edge, and if it takes me to a place that I haven't seen before, then I add it to the route, and I just keep going. And because I know this to be true, I don't have to worry about backtracking and stuff like this, so that's how I save that much time. But pretty tough if you did not know this one already, or you have to do the reduction in your head because people did it very quickly. I did it in 5 minutes. People did even faster, right? So wow, people are really fast actually. Well, I mean, I'm looking at the best people, of course, but still. Okay. maximum length of concatenated string. Okay, so this one, I mean, I think the first thing I noticed was just that n is 16, right? N is 16, I mean, I think you saw me do the math where then it's just 2 to the 16. Yeah, so it's 2 to the 16 times 26, something like that, which is fast enough. And essentially, that's what I did. You could actually do like this would actually be fast if you just do a recursion and kind of pass in things you've seen. And actually, I didn't even need this. I didn't need this to be an array rather. This could be sped up if you use a bit mask since it's only 26 characters. But you know, it's brute force, so there are not more ways to do it, and you could just do it. Yeah, this one's the tricky one. I honestly don't know how. I would love to kind of see how other people got it. And I struggle a lot with this one. I mean, if it was guaranteed to be axis aligned, meaning you can only, snap it on vertical or horizontal parts, then I would have gotten this probably very quickly, because that's a dynamic programming solution that's very, natural. I mean, essentially that's what I did. I will admit that I did Google this. I don't know if people do this during contests. I generally do not in the past, but I also feel like, I mean, yeah, I don't know. I don't know what the kind of accepted thing is, because this, I feel like this is a problem that people have just seen before. And once you hard code this one, the dynamic, and from what I gather, this is the smallest case in which this is true. And it's there as kind of a red herring. I feel like in the spirit of things, either they could make the problem so that like it's axis aligned, or just make it like even 12, then like you don't have this example, and then maybe the solution people would have worked their way to it, to what I did here, essentially just snapping it along a vertical or horizontal. But yeah, overall, I mean, I don't know, but that part, as it becomes dynamic programming, is straightforward. But unfortunately, that's the case. Because like there's this weird thing. I don't know what the right way is, so maybe I'll kind of do what you would call it, a retro later. Is this done-ish? Yeah, so okay, so I think I'm like 48th, which is okay. I mean, I think one thing that I'm trying to think is maybe like the Pew contest. Well, these, or they just know it. Maybe maybe I'll take a look at the contest later. But yeah, maybe I would. Yeah. Okay, cool. So 48th. I mean, I wish I did this during the real contest. I've been doing virtual contests pretty okay, but the real contest I've been just like a little bit off. But we'll see. Maybe I'll do one of the coming weeks. It's always tough because it's on Sunday or Saturday, like at 10 p.m. when I'm out and about. But all right, cool. All right, see ya.